Smart factories and smart manufacturing are the most spoken topics in the post-COVID world. And there are many attributes to talk about smart factories. The most prominent ones are connected, visible, and autonomous. Okay. Now, over the next 1 hour, we will speak to these five eminent CEOs to look at their perspectives on smart factory, how they have driven many of the initiatives in there, what are the way they are actually asking India to go about in the smart manufacturing route is what we are actually going to talk about. So I'll be moderating and we'll try to get the best from the CEOs for all of you. So let's start the session. Maybe we'll start with Krishna Kumar. Krishna Kumar, can we actually go with what is the term smart factory?
First and foremost, thanks for calling me on into this panel. It's really, I'm glad to interact with eminent people like Rohit and others. For me, smart factory is basically a connected factory, a connected workspace. We have heard about connected cars, connected vehicles. It's a connected workspace that we are talking about. And when I say a connected workspace, I am talking about the entire ecosystem. I'm talking about where we have a complete digitized network. It's a digital grid that's made, and we have the connected customers in its best form. I think it can be a connected ecosystem where you have the connected customers with an integrated supply chain and planning, a very integrated manufacturing setup, and including all the required paraphernalia with regards to quality and others, and the integrated final dispatch supply chain. It's a place where we have a very responsive, proactive, and a predictive environment, right? So what does it mean in terms of when we have the smart factory? What does it actually mean? It means that we are looking forward to have a workplace which is going to give us a regular and a consistent process performance, a place where we are going to have a consistency in production, both in terms of productivity as well as operational efficiencies, a place where we are going to talk about consistency in finished products, a place where we are going to talk about consistency in quality, and a place where we are going to talk about final outcome of the product and processes, which will end up in ensuring that we have supplies with delighted customers. So this basically calls for building up a network in the factory, and I'm sure we are going to have more questions on that. So I don't want to dwell too much on this particular thing, but that's what smart factory means too.
Thank you, Krishna Kumar. That's a wonderful start. So Sridhar, maybe pulling you in to look at from your perspective, okay, what you've seen your clients doing smart and how you have enabled smart.
Smart factory, I would really like to look at smart factory from a broader perspective and really call it smart manufacturing. And when I say manufacturing, I just don't mean pure manufacturing or production. The smart manufacturing starts from the design and engineering phase. So today in many organizations, the design and engineering, the production and the quality are all operating in silos, in various silos. Our whole idea is to connect all these three to a digital thread and ensure that your as designed part, as manufactured part, as measured part is one and the same. Typically today at the executive level, the CEOs are having a major issue that the intention of the design is something, the design is something else, the production is something else, and finally the measured quality is something else. So I would say, the designer may say I've designed a great part, the production guy may say I manufactured a great part, whereas the measurement guy will measure the part and say, hey, look at the tolerances on the part, look at the welding issues that you're really kind of having, and so this is as Krishna Kumar rightly said when he talked about connected workspace. I really want to say it has to be a connected organization. So we have to ensure to the customer that not only you're as designed, as intended, as designed, as manufactured, as measured is one and the same. So we are actually implementing these technologies across the organization, and we also done in our own manufacturing because we have manufactured a lot of CMM machines as well. So this is what is connecting the whole thing. So focus right from the design stage, because we need to ensure that 80% of the product cost is actually committed at 20% of the product life cycle. So any change later is going to drastically increase your product cost. So if you're able to take care of it at the right from the design stage and have a digital thread connecting all these various parameters of production and quality, this is what is smart manufacturing all about as far as Hexagon is concerned.
Excellent, excellent, Sridhar. Maulik, getting you in from a chemical perspective, what do you see as smart manufacturing?
Right. Thank you for that. To start off with, I want to say that Mr. Krishna Kumar and Sridhar shared a couple of very insightful points, that smart manufacturing includes everything from the way that it is designed all the way across all the moving parts, including material management, human movement, inventory control, as well as the layout to do it in an efficient way. In my opinion, smart factories are basically interconnected process plants that offer performance data to allow for optimized running of that factory. Right. So let's just be clear here. Now, solutions, you can use while the data that you get can be used to tweak parameters within a particular prescribed bandwidth, the real value for any smart manufacturing is allowing the operators time to be focused on the real outliers that can make or break future performance. So any smart manufacturing setup that allows the human being involved to focus on the outliers to drive higher productivity, that is smart.
Thank you. Thank you. Thank you, Maulik. Rohit, your perspectives from the metals business.
Sure. So I think some great points by all, by Krishna, Sridhar, and Maulik. I'll just add a little bit slightly different, actually build on the perspective that they shared, which is, a smart factory is a bit of one, obviously creating connected world, an ecosystem, not just internally, but also with their supply chain and customers. But within the plant, one of the key important elements you're trying to do is to try and convert the intuition and the learning that your experienced workers have built over 20, 30, 40 years at times into a little more scientific and structured approach, so that this is more sustainable and not left to ad hocism in the plant with a limited few people. So I think one part is, how do you convert and capture this nuanced learning that you've had to make decisions and operate and bring process control in the plant. The other aspect is around how do you ensure that you're capturing the data and analyzing it in a efficient manner. AI and data analytics is going through such a rapid change that you can do algorithms at speeds which were unthinkable earlier. And hence the process improvements and efficiencies you can bring at the shop floor are very, very, can transform, how you operate. For example, at Birla Copper, one of the things we have done is to create a digital twin for our smelters, right? Where depending on whatever different types of ores we put in, we can predict what happens at every part of the smelter inside, and hence manage the operating controls in a much more efficient manner than what historically we would do based on someone's experience or past experience. And I think that to me is the beauty of what a smart factory or a smart manufacturing can do. I think it is a little of sort of jargonized word today. Everyone says smart for everything, and it means different things for different people. But I think we're in the right direction. The only caveat I would sort of put is, look, as we talk of a digital and connected world, I think as you invest in smart manufacturing, you need to probably invest even more in the cyber security, because the moment you connect everything to digital world, you also open plants to big risks of something going wrong and people not knowing what to do with it, especially in metals or chemical plants. You have to ensure you keep building on this risk that you expose yourself to without knowing of a connected world.
Excellent, excellent, Rohit. That was a very comprehensive perspective. Sanjeev, you have been a career CEO, so how do you look at a smart factory from your perspective?
Yeah, I think, look, the good thing about going last is I think whatever needs to be spoken about smart factories as said. But let me bring in a couple of elements from my industry. I think being in healthcare, um, there are two things that keep us awake. One is the whole compliance bit. We are probably the most, what can I say, controlled industry besides banking. Yeah, so we need to ensure that we are fully compliant 100% of the time. We can't be even one time in thousand also we cannot be non-compliant. And the second is that we also deal with human lives. So for us, smart factories really mean that we will take no chances with quality, we'll take no chances with human lives, and we have to ensure that everything is properly done. So all our effort in smart factory management is all about ensuring that nothing goes wrong because the implication or the consequences are just too much. The second thing is in our industry, there is no scope for surprises. We cannot have a surprise outcome. So we therefore need to be very, very careful. Therefore, the data analytics required during smart factory management is something that is very, very crucial for our success. So that's probably the basis on which we have to operate. There are, of course, the added benefits of better manufacturing operations. There are, working capital management. There is production and capacity enhancement. All those things are related to smart factories. But those for us are, for many industries, would be the primary focus. For us, those are consequences of what we are doing right from a human life point of view. So that's how it turns a little bit different for us.
Excellent, excellent, Sanjeev. Sanjeev, maybe getting you in, extending your discussion. What are some of the changing customer needs in your business, which is driving you towards smart manufacturing?
So, Satish, that's a very important point. But I would just add customers and stakeholders both to it. The
Sure,
reason being, in our industry, what happens, the customer and the consumer are two different people sometimes. There is a doctor and
sure.
the patient. So, I think one is the regulatory environment. One is we work in highly regulated markets sometimes. So, the customer there expects us that anything that they want to check can be checked, even if remotely, even if on data, even anything, they are able to check it on in real time. So there is a regulatory say equation to it. um, the second thing, therefore, what we have to do is we have to ensure that every few months or every year we need to involve capex in such a way that we are evolving as per global standards. We just don't have the capacity to fall behind global standards because we will be out of the market otherwise. So there is that regulatory thing that makes us that much more, let's say, attentive to what are the standards and what is changing. The second customer need is that I think the customers also expect now, the let's say the customers in terms of the medical fraternity, they expect a product to have ease of delivery with the patients.
Mm.
So all of you took vaccine. You had an intramuscular vaccine, it pained for a day, you had a fever for a day. How would you like that a nasal vaccine comes in? But that can only happen if we have that level of smart factories. So that is very, very important. You take many, some people might be taking an insulin injection. How much they would be happy to have an insulin tablet, and it's nearly scientifically impossible at the moment. But there are things which mean that smart factories have to deliver a very different outcome for us, and therefore the customer needs are continuously changing on what they want and how ease of their delivery and their say delivery to patients happen. While on the other hand, patients also expect something different. Earlier used to have a cough syrup where you had 20 let's say indicate, say 20 ways of doing it. You need to put warm water, shake until this level, while the doctor says, this creates a headache for me. If I prescribe this, the patient keeps coming back, what to do? So again, smart factory for us would also mean that we develop products in such a way that would mean that patients also have ease of consumption. So it's a very slightly different industry. So the customers and the stakeholders are expecting very many different things from us. We need to keep that in mind. And the third aspect that we have is that if there are For example, during the pandemic, we were the largest producer of amphotericin B, and you had the mucormycosis black fungus story. We had to increase capacity 3 times in no time. But because our factory was a reasonably smart factory, we could double it in no time. So that kind of responses we have to give. So it is also depending on public health situations. So maybe it's a slightly different industry, but that's what customer needs are for us.
Excellent, excellent. You touched us, Sanjeev. All of us were able to relate the moment you touched vaccination. So fantastic. Rohit, how do you see that from the metals and the industrial markets perspective, the changing customer needs?
So, I think there are 5 things that probably are driving this for us. The first and the foremost is actually safety, not so distinct from what Sanjeev was saying. For factories, safety is one of the most important elements. And actually, one of our first large-scale executions of a smart solution was in safety. We started with, just using cameras to track how many people are wearing the right PPEs in the zones that they're supposed to go into, right? And using that. And actually, as COVID hit, this came in very handy because we then were able to repurpose this for the same infrastructure to actually also look at COVID management at the plant, right? So I think one is obviously safety, and which is more for the internal customers, that we need to leverage this. This also includes things around process controls, process alerts, and warnings, and the whole infrastructure around that we are creating. I think the second, the most important element is around the quality and process by, or product by process and quality by process, which most industries are moving to. Historically, in Indian manufacturing, we have not been that focused in quality in the country, right? We have just said, okay, if this is a minimum threshold, you ensure you over-design the product to actually just ensure it meets that spec, and it can be over-designed significantly. But I think increasingly customers are demanding 3 Sigma type product. In some cases, like in copper, you make 99.99% copper, right? So you have to get into a very fine range of process, and this is helping us. Process control and smart solutions are helping us drive that process control throughout the process value chain. Third, I think big one for us is obviously, I think cost is a continuous treadmill. You need to keep working on it, and hence using this to drive productivity, to improve recoveries and yields is an important element for, I think, most manufacturing companies. And that's the only way you can keep the pricing in control. The fourth one, which I think Sanjeev also mentioned, though for us it's probably a little different, is how can you use this information and insights to drive faster new product development? Because I think in manufacturing, for example, at Hindalco, one of our focus areas is how do we replace stuff which is getting imported into the country and not being manufactured here. And hence, we are using a lot of the smart solutions to develop NPD and new products much faster, capturing the learnings from previous in a systematic way, and shortening the new product launches that we do. And I think the final one is around the supply chain. How do you make the supply chain seamless for customers? There was times, I remember 10 years ago, half of your time of your sales force, maybe more than half, would just go on, where is the truck reached, the customer asking, right? Has it left? Has it, literally, like, you would chase up 5-10 times for the same truck before it reaches. And, copper is a very expensive material. So, for our teams, it was a nightmare. And I think over time, we have been able to use some of the technologies to make this seamless, make it transparent, leverage some of the new solutions developed outside for other industries, adapted to us for serving our customers, and the just-in-time information at hand, always kind of a system, which is fantastic.
Excellent, Rohit. I think that's very comprehensive. Now, of course, all of us agree that, of course, smart manufacturing is really helping us to, deliver to customer as well as stakeholders. Maybe we go a little more deep dive. Maybe Krishna Kumar, if you can actually share some specific examples and initiatives you are driving in your organization towards smart manufacturing.
Yeah. I really like some things that what Sanjeev and Rohit have said. See, the drive can be from the customer's end, or it can be from a product end, it can be from a process end. But what is important is we'll have to clearly identify as to what we really want to achieve. The end state is very important for us to really visualize. And I feel that, creating a good value stream map and ensuring that, okay, this is where you are today and this is where we want to reach over a period of time with regards to process, products, and, the other deliverables that we are talking about can be then achieved in a very, very systematic way. I can give you a couple of examples. Let me just give the perspective of what we did in one of the, let's say, a integrated shop that we had, where we did, let's say there was a forging being done and then subsequently machining. And I can tell you that the whole factory we integrated in such a way that we are able to see the processes, integrate the entire processes along with all the heat treatment and other requirements, the furnaces and the machining lines and the inspection lines. And it was done with, you have to go very systematically. First you'll have to go with sensitizations, ensure that you have the big data catch up that is required, have a very good data analytics that is necessary. And also, I think Sanjeev talked about this, with regards to having the augmented reality as well as the artificial intelligence to drive the whole process with regards to what you want to do with the ML and other things that we want to achieve on the machine maintenance and, the regular operations of the machines. So it was done in such a way that, on a motion board, we were able to visualize everything. Sitting in an office, we were able to see all the processes that's happening. And Rohit already talked about the digital twins. It really helps in ensuring that you can see the processes well in augmented reality. And we were able to completely see what's happening in the furnaces, including the temperatures in various zones, ensuring that you can have feedback mechanisms, the control loops which were clearly put in, which was ensuring that if something is going wrong in the process, we were able to send let's say a WhatsApp message or a message to one of the maintenance guys with the mobile on his mobile, so that he'll be able to get the alert and immediately run and get the things rectified. And this also helped a lot in terms of on the machining lines. We were able to get alerts with regards to the machine operations, with regards to the processes, with regards to the product quality, because there's a good feedback loop that was already factored in. And we were able to get the product quality fairly in a manner which was completely monitored by the system, and it was completely foolproof, so to a fair extent. Now if it goes beyond the various certain limits, then you need help, and that's where human intervention is required. And that's the time when you have to ensure that proper feedbacks are given to the right people to enable them to come and intervene in the line. But otherwise, the process becomes fairly integrated, and it was ensuring that we were able to get the product of the right quality at the right cycle times. We were able to hit all the production efficiencies, operational efficiencies. I can tell you on an average, we had almost close to a 24 to 25% improvement in productivity, which is a huge improvement, because we were also running it during the lunch times and other things. Lines were completely running during those lunch hours. The second area was on cell manufacturing. Again, you have to design as to what exactly you want to achieve. There could be improvement in processes as the main goal. There could be improvement in the product quality as the main goal. There could be improvement in, let's say, manpower cost as the main goal, or it could be, from a point of view of that the lines, that the product needs to be manufactured with the right quality. So while we do all this, once we have decided that, on one of our lines for the export lines, we have been able to get 15 odd processes completely integrated, where you have sensitization, machines talking to each other, you have processes talking to each other, literally, in the sense that if suppose there is a quality check done with one of the, let's say, a Marpos instrument, which tells that, okay, the product quality is going slightly off the mean, then a correction factor is already applied by the machine itself. Now, that way, all the processes gets completely integrated. So we have been able to do that on the line. So these are some of the examples. The benefits are huge, and but we have to be very clear that it has not to be done for the sake of getting a, let's say, smart factory done. It has to be done with a clear purpose of what we want to achieve, and that's what will give in the right benefits to us.
Excellent, excellent, Krishna Kumar. I think those are fantastic achievements, and would I would say excite anyone who is actually hearing to go in for that. Maulik, pulling you in from a chemical process perspective, what are some of the examples and initiatives you have done in your business?
Okay, so Satish, I think I'll start off by giving examples of one, a couple of things that we did wrong, because there's a lot of learning that comes from that as well. So as I mentioned, I'll start with a failure example. And the failure example was in putting up a smart factory in a product where we had a significant amount of backward integration. We thought we understood the market, and we thought, it's the scale of the plant that we put up. At that time, we decided to put up the largest plant in the world, because we said we're backward integrated. We're the only company who is backward integrated, and therefore we leverage scale all across the way. And we failed miserably. To this date, we have not been able to cross 60% of the plant utilization, even though there is demand. And the learning that we had, one, was smart manufacturing is certainly easier to do when you have some variations in raw materials, but where the number of SKUs is fairly limited. Here, and in Deepak, we have by and large a lot of experience in manufacturing at scale products which have generally just 3, 4, maybe 5 SKUs at most, right? Now this goes completely out of the window when you have more than 100 SKUs. There's just different permutation combinations required to make each of these SKUs with which maybe about 4 or 5 raw materials that are different, but the big ones are the same. And that's also fine if you have reactor sizes that are at small, medium, large. But if all your reactors are large, right, and you have SKUs which are in the dozens, in our case it was more than 100, you are not going to be able to run that plant as efficiently because you've set yourself up against a wall. Now, compounding this problem was the assumption that skilled manpower is very easily available, and also that the OEM will understand our plant conditions enough to give us support when needed. These are assumptions that are easy to make when you're going ahead with just paper and just understanding from only a theoretical point of view or only from the consultant's point of view, without actually taking that real level of on-ground clarity. And therein also is the problem of the first mover disadvantage, right? Because you have to learn everything and you have to teach everything. So we learned the hard way not to get into automation where there is already a challenge in the number of SKUs that are required, where there is a desire for a lot of manufacturing companies and technology companies to get into smart, but where there is no real on-ground example of that being done. And third thing is, in India, in places like Gujarat, especially places like Bharuch and Dahej, do not take for granted the availability and consistency of skilled manpower. So we used these learnings and we put up a large-scale phenol plant. We did this in 2018 and 2018. And we've put in advanced process controls along with a lot of IoT about material going in, material going out. And herein we had a theory of constraint that was put in place. This is the amount of land we had. This is the amount of money we had. That's it. We didn't have any more. I'm pretty sure that we would have been less automated if we had more resources. Nonetheless, we put our learning from our failure to work, and keeping in mind that the number of SKUs there was fairly limited. It was only 2, 3 at that time. We put up a nameplate capacity of 2 lakh tons, and that was crossed within the first 3 months of the plant being commissioned. So till this date, we go anywhere between 120 and 150% of our nameplate capacity, to the extent where we don't, when we're reviewing internally, we don't talk about capacity anymore. Now we talk about capability. And the reason that we were able to put this significant productivity driver to work was actually because we had very, very few SKUs. It was also because the value that comes out, it comes from just a particular mixing of 3, maybe 4 raw materials, not more than that. So when you have variations, there is a different kind of automation that one can think about and learn from Deepak's mistake. That every single kind of automation or smart factory isn't like any other one. Like, do it for the goal. Don't do it because it is the flavor of the year. And certainly, what it has also helped us do over a period of time is significantly improve the cost of conversion, the energy utilization, getting the right enthalpy, and making sure that whether we're using 4800 GCV, 4200 GCV, 3800 GCV, all of these things are allowing us to ensure that we get the right steam cost, which is the most important. So that's an example where we've done it right, and an example where we've done it wrong. One last point that I'll just mention is that a lot of companies here, including what the Birla companies would have to go through. While there's a lot of production, there is a lot of material movement, both inward and outward. So you have either vehicles coming in full of one thing and going out full of another thing. You have vehicles coming in full and going out empty, or you have vehicles coming in empty, going out full. These are the 3 permutations that you can have. And they would also have realized that connecting the plant operations to the inventory management, to the inward and outward of vehicles, along with ensuring that there are no traffic jams along within the plant, will allow it to operate seamlessly. Otherwise, you're working at the lowest common denominator, whatever that is.
Excellent, excellent, Maulik. I think I think a lot, because it's not that every path is green, and there have been also learnings which come in. I think audience would have actually got much more from your perspective, and your perspective on capacity versus capability was very interesting to look at. So moving to Sridhar. Sridhar, you have been helping a lot of your clients, okay? And as you actually gave your introduction, you also talked about product design and how you actually helped. And maybe one of the interesting perspectives when I did one-on-one with you was how you leverage simulation as a means for actually, anticipating many of them. Can you throw some light on that?
Sure. See, let me just share one slide. I just wanted to share one slide for the benefit of all the users out there. So if you really look at it, we at Hexagon not only provide a service to help customers to become to adopt smart manufacturing, but we also manufacture our own CMM machines, whether it is portable or stationary, even a high-end CMM machine, which can measure up to 1/10 of a micron, which is less than a strand of a human hair. So we ensure that we practice what we preach, and we have made our own factory completely smart. So this is what we do from a service perspective. So there is simulation everywhere. So when it is a design and engineering, we simulate every aspect of it, not only the structural simulation, also the thermal simulation, also the fluid structure simulation, the acoustic simulation, because the regulations for acoustics is also becoming very, very critical. Material simulation, what kind of materials should we use? Today, a lot of people are actually using a different kind of the composites and everything, the fiber reinforcements, those. How do we ensure that the whole material simulation can be done? Now go to the manufacturing facility, whether you want to manufacture the traditional way of manufacturing, like taking a block and cutting the block, or additive way of manufacturing, start building blocks and manufacture the whole thing. So we can simulate the whole thing to ensure that you get it right the first time. And again, ensure that whatever product is done, the product develops, you kind of do a measurement, do a metrology with the CMMs that we have. And if you want, you can do a reverse engineering, scan the whole product with the CMM machines, and compare that original design with the final design and see what are the gaps and take these learnings and pass on these learnings into a digital thread and get the company right the first time. So we have been we have been doing this for about last 5 years, and we have about factories across the globe, in mainly in China, Germany, France, and the US. And now recently we have opened a factory in China which is 100% autonomous and 100% smart. And there, where we are able to go take our customers and say, this is how your future factory kind of look like. So one is transforming an existing factory or start a completely greenfield project. So simulation is extremely important, and you can do today. Your hardware technology has also gone up in such a way where you can simulate the most realistic situation in your design space, in your manufacturing space, and finally go measure these parts as well. So we do a lot of simulation work. We provide this technology to our customers, also do a lot of simulation for our own product as well. So I would only say the mantra should be simulate, simulate, simulate before you actually kind of go in a physical space. So today you do a lot of work in the digital space and then get it right the first time that is in the physical space. This will really help you to drastically reduce our cost. So we did a survey recently among our customers, and some of the most conservative estimates what they have given us is they have reduced the OPEX, increased the gross margins, labor productivity, increase the reliability, reduce the maintenance cost, and also reduce the inspection by about 50% by doing a lot of automation on the inspection side as well. So this is the true data, which is a customer survey from many of our customers, and this is the direction that we have to go across the globe. I would recommend every Indian company to really start looking this way, and there's a lot of benefits of that to really implement these technologies.
Thanks, Sridhar. That was an interesting perspective on simulation, and of course, we all learn simulate, and of course, we'll definitely adopt that. Shifting gears, maybe when we actually get into a smart manufacturing as an initiative, of course, the company alone cannot do that. It needs to actually ally with a lot of partners to go about delivering. Maybe pulling you in, Sanjeev, here, how can startup ecosystem and the companies can work together in getting more smarter or driving smart manufacturing?
Yeah, I think, Satish, there is one principal reason why startups can contribute. And the principal reason is what happens when you want to have a smart factory is skill set. Your workers, your employees, you cannot keep changing just for the sake of it and bring in new skill and therefore throw the change the workers that you have. That is not the right thing to do. You have to upskill your workers. You have to upskill the people that you have to ensure that they become valuable for the smart factories. So there is a connectivity in the terms that what you need for change there. In terms of how do you want to change the factory, there are a lot of startups who can help you through the design thinking and through how this should be approached. And we have seen some of those design thinkers who come in and really do a very, very good job. So that, and there are basically startup companies. They are not some big companies, or they're very enthusiastic youngsters who try and do things and bring in technology in a very interesting way. What they need is encouragement. They need expression of what they want to do. So we can also convert this into a mentorship for startups, saying that, look, you do this for us, it's okay. And they're willing to, what we need to do is don't misuse them by not paying them properly. Pay them well. Pay what you would pay to a regular consultant that you would do. So that helps the startup ecosystem. On the other hand, because of they coming in, they're very quick in gamifying everything and ensuring that the workers learn skills in a very, very encouraging way, in a fun way, and they really help a lot. So we've seen some of these things happening. Now, one of the, I don't want to name it, but one of those startups that from Pune actually, which tried to do this for us in some other context, is now, we were the first ones to help them, and they are now a unicorn. So these just happen. So I think the ability for us to be broad-minded, to include startups in this ecosystem, to ensure that they benefit and we benefit, is something that would help. Let's not try and make this, this is an opportunity where we can actually use talent from startups to really do something special to build a smart factory. One way to do it is get global consultants and get it done, and or call Satish in and say, okay, help us through this. But the other way is to help startups and really create a new ecosystem. And actually, we have tried this in many ways, and we find it a fun story that how we can help startups and we get help. So probably it's a little different, but this is how we are looking at startups and smart factory ecosystem.
Thank you, Sanjeev. I think that's a very, very interesting perspectives. Not only from a smart manufacturing perspective, but also how do we promote enthusiasm of youngsters. And by the way, I've noted that opportunity. I'll actually reach to you separately. Sir Rohit, what's been your perspective in terms of what do you think the startups should do differently, or how should they align to meet this need?
Yeah. So I think I echo what Sanjeev was saying. In fact, I think the way to think about this actually first from a larger company perspective is, historically most of us have operated in the Apple model where R&D has been kept closely guarded in-house for everything, right? Outside the world is changing so fast that there is no way you can invest at the scale that is required to upgrade your people, upgrade your knowledge to keep up with what's happening outside. So, sooner or later you will get outdated in the larger ecosystem outside. Hence, I think as manufacturing companies, we need to think a little bit more around the Android type model, where you actually create an open source R&D, right? And this startup ecosystem, is a great opportunity for us to leverage an open house R&D. Where what it requires from us is being able to think through and volatilize some of the needs that we have in a little clear terms, give it out to the open community, and let them come up with solutions. So as a group, as AVG, we do a lot of these. We started this concept of Biz Labs, which was where over the last few years, we have reached out to more than 1,000+ startups across different platforms to say, look, this is a problem that we have. Come and solve it for us, right? And for them, we give the platform. We, like Sanjeev said, we pay them well. And for us, actually, even after paying them well, it's still a much lower cost and faster solution than many times, doing it, ourselves, right? And I think with this new thinking comes in. And actually, from a manufacturing perspective, I think something which we have not used as well as IT or maybe the service space is actually if we are able to create this in a larger scale in the country, you will bring back, the lost mojo in manufacturing to revive the sector and make it an exciting place for youngsters to also come in. So I think to me, it's a great opportunity as a country and as an industry. We should not lose it. Think of it as how can we create a bit more of a open architecture where you can bring in people from outside for short stints, not just startups, I would say, but even colleges, right? I think universities and engineering colleges need to actually work hand in hand. So, for example, we do a lot of projects with BITS, Pilani, and some of the other big institutes where we get their students or professors and say, look, this is a problem, solve it for us. We'll pay you well, and use it. So I think it's a great opportunity, and I see a lot of I'm glad to hear that Sanjeev was mentioning that some of the unicorns are coming now in the manufacturing space, and I think increasingly we'll find more and more unicorns in the manufacturing space and not just in the digital space per se.
So Rohit, maybe pulling in, of course, and that's actually about leveraging the startup ecosystem. And one of the challenges I've seen across for this, smart manufacturing taking off is also about how do you handle people? At the end of the day, it's a transformation. Your own in-house people are actually there. Yes. So what is your suggestion and your perspective of how should that change be handled?
Yeah, no, I think a very valid point. And I think one of the speakers earlier had mentioned about this. This is, I think, a change management program, especially for most of the large companies, right? Where you have a very large middle management, which has over the years done it manually, done it in a certain way, have a lot of knowledge. Most of us are now getting youngsters whom we are trying to bring in, saying, bring energy. And many times we end up pitting these two against each other. Whereas I think the way to think about this is how do we collaborate and make them actually partners versus adversaries in the organization. And I think that is, one most important element which you have to do it carefully. We have been consciously trying to create that environment where we are actually doing reverse mentoring, for example, for some of our middle management, by the young GETs that we get on saying, look, teach them digital stuff, make them comfortable with digital, right? And many of the middle management have actually, found it very, very useful, by being trained or reverse mentored by a fresh GT on technology, right? Making their lives easier. So I think one is that part. Second, I think you need to think and bring a lot more structured analytical thinking in this in the organization. So, we're doing some trainings. We are thinking of some programs where we provide opportunity for people to ask the right questions, even if you don't know the tools. Right? Can you start asking the right questions that data could actually begin to provide to you? And I think the third and the most important part I would say is, even as we digitize, finally, what are you trying to do? You're trying to convert the knowledge built over the years into a digital system, analytical system, which is autonomous, proactive, and thinking on its own. But the important part for us to think about is that knowledge of how that works is not lost in the organization. Today, it is fine. The people who've codified that, algorithm are in the business. But 5 years down the line, people will look at it as a black box. And that we cannot allow to happen in a manufacturing setup. We need people who remember these algorithms over the years and are able to improve on it. Right? And otherwise, it will become like, I'm sure all our fathers knew how to fix a car when it stopped on the road. Today, most of us will say, I don't know what to do with the car with swap, just call the agency and replace the part, right? So I think in manufacturing, we'll have to keep that intuition, the knowledge also alive, even as we codify doing this. And this is where the middle management who have that experience is very, very important and needs to be also nurtured as we drive this cultural transformation.
Excellent, Rohit. I think that's a very interesting perspective. Maulik, pulling you in, what are some of the initiatives you have done and driving it within your organization, or what you've seen?
Okay, so a couple of the places where we have seen digital and smart being used, as I mentioned, one is ensuring that learning, good and bad learning, is not lost to the organization, is kept fungible between BUs in the organization, because at the end of the day, you need to just translate it a little bit to make it more applicable to your plant, to your process. So one is ensuring that there is a ready reckoner and a learning available to everybody, and it's especially at the plant level. So as has been mentioned, we keep the learning as democratic as possible. The other thing that we have tried to do is not take huge leaps and bounds. My biggest concern when people look at flavors of the season is to, when I see people go all in, right, and take the biggest bets possible, literally put the success or failure of their investment on risk. Now, sometimes that's a great thing, right? Because that means that you have significant skin in the game. You have no choice but to make it work. But the problem is that this works when it's a small initiative, it's a small team, it is the gap between the person on the floor and the person who is the risk taker, the promoter, it's narrow. Once this gap increases, so does the need for buy-in. And so what we have tried to do is also, wherever we are implementing something which is quote unquote smart or has a very large and differentiated digital interface, we, sorry to say, but we don't just go with the word of the consultant that yes, this is a good idea, yes, this will be easy, yes, it will be done. Because most of the times when we've had this interaction, what has happened is the prognosis has been, look, the solution works, the problem is the adoption, and that's not our problem, that's your problem, right? So what we've tried to do as much as possible is, when we put in even a thought behind going digital on a performance system, we have the people who will be involved in putting it up on the ground and running it go and visit as many plants as possible, where they're able to see what happens when such a thing doesn't exist, as well as when such a thing exists. So when the people on the floor are your ambassadors, they are already incentivized to see how to ensure that it succeeds. After that, you work with them in order to create their own KPIs and KRAs in such a way that your meets achievements level, the status quo is what the plant can do anyways without any level of automation. Now, if they want to go beyond that, it is where the automation is required. So you need to create this pull at the ground level, because otherwise a ground level person is very, very happy being conservative and risk averse. Why should this person try something new? It's not in this person's best interest to try something. It's in this person's best interests to do what is required to be done at the very lowest level, the most convenient level, because change comes at a cost, and change means that person's neck is on the line. How do you make sure that that person's neck is not on the line when you're asking him to change? So you make him an ambassador, you make him a change champion. You make that happen by making sure that he gains more than he loses by recommending the change. So these are some of the learnings that we've had. Some we've learned at the hard way. Some we've learned just by asking people on the ground. Okay, it's not about whether the productivity will improve by 5% or 10%, because at the end of the day, for you, what matters is, okay, what are you able to do with a significant level of confidence where you can teach people under you? Sorry, that's also one more point. Giving people on the ground the opportunity to teach and train other people, creating these, train the trainer modules and programs means that, they have to know it well enough that they can train somebody else. So they become invested in learning themselves. So it's, for us, the biggest challenges were not with regards to, getting the right consultant or the right technology partner. We're very frugal in that sense. So we do a lot of homework into that. The challenge came on the ground when you put pedal to the metal and you found that the process cracked at the adoption level. So we've learned and we've tried to implement changes at the adoption level by taking these people into confidence, making that change easier for them.
Excellent, Maulik. I think that's an input of change champions and rewarding them well, while they're taking risks is a very, very important perspective, not only for smart manufacturing, but I think overall any kind of a transformation itself is very, very relevant. And thanks for that, Maulik. Maybe Krishna Kumar, getting you in terms of, now what kind of initiatives the government should take to promote smart manufacturing and, make it easy for many companies to adopt?
Yeah, sure. Before I go into the government, what government should do, I would like to echo what Rohit and Maulik said. I'll just sum it up with one sentence. I think one of the important things to do as far as smart factory is concerned is you will have to drive digital from the top, but you will have to execute it from the bottom. Now, what's very important by this is unless you have the buy-in, as what rightly Maulik said, you normally see that it tends to fade. The whole process, then they find out some reasons of not of bypassing some of the processes, of ensuring that your sensors are all bypassed and the process still runs. So unless you have the buy-in, it will not work. So, and while we do upskilling and learnings are always fungible and all that is there, but ensure that there is a good buy-in from the bottom. From a government perspective, I feel that there is a need to motivate the startup ecosystem as well as incentivize them, very clearly based on their ideas. And, to what Rohit said earlier, I think it's much, Rohit and as well as Sanjeev, I think it's much easier for me. I find it difficult to do it in a well-established factory rather than in a startup system. Frankly, I would put it this way that, making a smart factory in a startup is much more easier and faster. And, there is, of course, that initial need of higher capex, but I think that's still workable, and when you're able to clearly prove that what is the kind of results that you're going to get with the help of the smart factory. So I think the government needs to really attract more, let's say, ideas, more youngsters into this towards research and development and developing the new manufacturing technologies, and also ensuring that they are completely adapted to smart manufacturing. If you really see what government is doing today, is actually incentivizing products. There are not many incentivization that's taking place for process improvements. I don't think there is any. In fact, if you really look backwards, there's hardly any incentives that the government has given for any huge process improvements. So I would suggest that the government should work on this and try to bring in some kind of incentivization of processes. Now, this can be done by various means. Of course, we'll have to see that the money is not pilfered, but we'll have to really see as to how it can be, exercised. And I'm sure there can be ways found out to do that. And once the rules and guidelines are made and a well integrated process set up, I think it will really help the ecosystem. So that's what I look forward to, more incentives from the government.
Excellent, Krishna Kumar. That's a good perspective, and I'm sure whoever has to hear would have actually heard it from this panel. So this is a panel, which we can actually talk for a day long, and there are a lot of perspectives each of you carry. But unfortunately, we're actually coming at the last 2 minutes of the panel session. So maybe what would be your one-line recommendation to each of the CEOs who are actually listening on the smart manufacturing? Maybe starting with Krishna Kumar. One-line recommendation.
Well, one-line recommendation would be go digital today. Okay, think big, start small, and scale big.
Awesome. Sanjeev.
I'll make it simple that I would say don't make smart factories a fashion statement. Look at your needs and look at what future holds for you and make your decisions.
Fantastic. Sridhar.
I totally endorse what Krishna Kumar said. Start today. I don't think you have a choice. Start today, and definitely yes. Identify those areas which are easy to implement. So start small, think big, start small, and scale fast. And today we can actually do it. So that's what I would say to all the CEOs.
Awesome. Maulik.
Okay. What my recommendation would be is stop thinking about this as an automation versus human question. And honestly, stop thinking about it as smart manufacturing. These are data collection engines and they offer data. Smart is what your people will be when they do use that data to make their better decisions. So it's not the manufacturing that will be smart. Don't leave it to the manufacturing and ignore the human.
Fantastic. Rohit.
So I'll just say, I think one, embrace it, drive it as a cultural transformation and not just a manufacturing transformation, but a larger cultural transformation to deliver the next phase of your business strategy. And I think finally, I would say a great opportunity for manufacturing to bring the mojo back into manufacturing and draw the best of talent into the sector.
Awesome. I think it was a very fantastic finish. I think really have enjoyed the panel, listening to all your perspectives. And I think it's a very short, tight panel. Okay. And to go over looking at, hope all of you have enjoyed the panel. Thank you.
Thank you.